Hello. This recording video will cover sections 10.3 and 10.4 on the topic of inflation in chapter 10. Of course, you should always go to the start page when you go to Blackboard and check out the bottom of the start page has the revised schedule of assignments. You should read in your textbook, your ebook, whatever you prefer, pages 312 to 318, which covers these two sections. View this video, and you're responsible for all of these notes that will also be posted on Blackboard with this video. And if you really want to make a good grade in the course, work as many problems at the end of each chapter as you can. All of that is what we say every class. It hasn't changed. Section 10.3 deals with making adjustments due to inflation. The author describes a future worth cases, actually 4 of them, and we're going to go through those in this lecture. The author has not really integrated inflation very well throughout the course. It's just kind of focused on this particular chapter, and so it's unclear whether you really whether in the rest of the book we're considering inflation or not, and so that's one of the shortcomings of I think the lesson. I think it's important that you understand inflation, and then if you can incorporate it into your economic analysis, that is something you should be doing. The first case that the author discusses or creates essentially is to find the number of future or then current. Remember, future dollars from the last lecture are called then current dollars, including both the interest that you will earn, what is called the real interest rate, and the inflation. So we're trying to include both. In that case, we use what we call the market rate. The market rate was, the symbol used was I sub F, which means that I contains the inflation rate F. So the future number of dollars is the present number times 1 plus I sub F to the n power. Well, that's the same equation, except throughout the course we've been using I, which the author says is the real rate. Okay, the market rate, in fact, you could argue is the real rate, but I shouldn't say that. I don't want to confuse you. The rate that you get when you do financial transactions always includes inflation. So, but we haven't been using that as such in the course. So if you use your symbolic formula, it's just P find F given P at rate I sub F for n periods. I'm not sure why this is here or this is here. I don't think I need either of those two things. So I'll take those out, and when I post this it won't have those. So that's the equation, and he says where he defines the market rate I sub f equal, we did this in the last class, but I'm just repeating it here. That's equation 10.6, and we use this equation a lot, is I plus f plus I times f, okay? And so here's an example of this case. The present value is $1,000. The number of years is 10. The market rate, I sub f, is 10%, and the inflation rate is 4%. Remember, I sub f has this inflation rate embedded in it. Okay, so it's already there. Okay, the author says determine f, that is a future number of dollars, in 4 different cases, and these are the 4 there are 4 cases, but the first case, case 1, we're going to find the actual future amount accumulated, or owed if you were borrowing that $1,000 in this account. Okay, so you use the market rate and you find f, so that is equation 10.7. Okay, so we just plug into equation 10.7, f equals p times f given p, I sub f, and n, I sub f is 10%, n is 7. We plug in, we get $1,948. He says this case will correctly predict the amount of capital needed at a future time to overcome the effects of inflation, plus realize a stated rate of return. So that's what we are accomplishing there. So the future value is $1,948. So the second case is where you wish to find the actual purchasing power of the future or then current dollars. Remember from the last class, the purchasing power was called the constant value dollars, or today's dollars, and CV dollars, constant value. Well, the constant value dollars are future dollars reduced by the inflation rate. So what we have to do is say constant value dollars equals purchasing power of f, which is equal to f, which is p times 1 plus I sub f to the n, which we just did in the last case. But then we have to take out the inflation. So we divide by 1 plus f to the n power. And that removes the reduced buying power due to inflation. Essentially, it must reduce the purchasing power of the actual future dollars due to inflation. And that's what we're doing here by basically dividing by 1 plus f to the n. Or another way to do it is to multiply by 1 plus f to the minus n. And we know what this is. This is p given f at the rate f for n periods. Okay, so in terms of this formula, in terms of your symbolic formula, the purchasing power of f equals p times f given p. So we're inflating it, f given p. We're moving it out to the future at the market rate, I sub f for n periods, and then we're kind of deflating it to get a purchasing power number. Okay, so this is really, and I'll post it like this, this is CV equals, that is a constant value is equal to the purchasing power of the future value. Okay, and so when we go through this, case 2, the future value of the purchasing power, the future purchasing power in CV dollars for the estimated is given by this. So we basically take that 1948 that we got in the last case 1, and we got to pull out the inflation. Okay, so we were given that the inflation rate was 4%. So we're going to divide by 1.04 to the 7th power. And when we do that, we're basically executing any one of these three equations. They're all the same. We get that even though maybe this account will have $1,948 at the end of year 7, what it would buy in today's goods and services, because they'll cost more, would only be $1,480 worth of stuff. That's the constant value term. And I would rather we make sure we know that's constant value of the F dollars. And actually, this is purchasing power. Don't forget that. Purchasing power of the F. It's the F dollars is this much. That's how many dollars is there. But in terms of what they would buy, because you're buying things 7 years from now if you leave the money there, okay? So it has to be reduced by the inflation rate. That's what the author discusses there. So the next case, or actually he discusses this the same case in another way. He says one thing we could do, instead of basically inflating at the market rate and then deflating, so to speak, at the inflation rate, we could simply just use the real rate, the I. And he says if we solve the equation 6 for I, remember equation 6 is I sub f equals I plus f plus the product I times f. And I is the real rate as shown below. So if we solve this equation, we factor out the I from the first and third term, we get I times 1 plus f, and then we keep the f over here, and then we divide by the 1 plus f to get I, and then subtract f from both sides. We get I equals I sub r minus f divided by 1 plus f. And that's the equation 10.9. Just use that I then in the to get the constant value of the future dollars. So the author goes through that process here to give you the I value. He uses the numbers. Remember, I sub f was 10% and f was 4% in the original statement of the problem. So we get I sub f minus f, that's 10% minus 4% in the numerator, and then we divide that by 1 plus f, which is 1.04. We get 5.77% as our real rate, okay? And then we have the constant value or the purchasing, I'll say constant value equal purchasing power of F equals 1,000 F given P at rate I for n periods. That's 1488. So it gives us the same value as using the market rate and then deflating it. That's what we did here to get 1488. We used the market rate to get $1,948, but they'll only buy that many dollars worth of goods and services if you were using your money now to buy those goods and services. So this is still more than $1,000. So you've gained ground, so to speak, in buying power by investing your money at 10%, okay, but you haven't gained the full 10% because inflation has eaten up some of that, okay. The full 10% gain would mean that you could buy $1,948 worth of goods and services. Okay, so the third case that the author discusses is the number of future dollars at time n to maintain the same purchasing power as P dollars today. In other words, all you want to do is find the number of dollars that will buy the same number of goods and services as $1,000 will buy now. That was P, remember. P was $1,000. In this case, all you have to do is find the future value at the inflation rate. So the future value in terms of buying $1,000 worth of goods and services is P, which is 1,000, F given P. F is 4%, N is 7 periods, 7 years, and he gets $1,316. So if you were to invest your money at 4%, all you would be, you would have more money at time 7. You'd have this many dollars, but that many dollars would buy the same number of goods and services at time 7 that $1,000 will buy now. That's what that means. The last case, then, the fourth case, is really not a new case at all. He's just substituting the mar for the real I, okay? That's just substituting for I. So he's saying that if you want to know how many dollars will be there in the future, you take P times 1 plus the mar R. What's mar R? I'm sorry, mar sub F. Mar sub F is the market mar, the market mar. Remember, if it's I sub F, it's the market rate. Well, mar is a rate. It's a minimum attractive rate of return. And if you include inflation in that, then it's mar sub F. And you would raise that to the n power to get the future value. And so if you substitute the mar for I in equation 610, remember this is equation 610 again, I sub F equal 1 plus F plus IF. This yields mar sub F equals mar plus F. This is the real minimum attractive rate of return. This is the inflation rate. And then this is the product of the two. That gives you mar sub F, just like I gave you that product, okay? So when we solve case 4 using mar F, we're just basically going to get the same result that we got in case 1, okay? We want to both maintain we want to account for inflation, and we also want to earn a rate of return. But understanding that the real rate of return that we're earning above inflation is 5.77%. And this is the market rate that we're using, 10%. So now I'm going to work, I'm going to cover section 10.4 very briefly. Calculations adjusted for inflation, annual worth calculations. All he says is basically you can boil this down to use the market rate I sub R when calculating annual worth. Okay, and we know how to get I sub R from equation 10.6, and so the next, I'm going to work a couple of problems, example problems for you. I'm not sure, I can't recall these being in the book. These are problems that I have from my notes. How much can the manufacturer of superconducting magnetic energy storage systems afford to spend now? Okay, so that's a P. Okay, on new equipment in lieu of spending $75,000 4 years from now. Okay, so if they spend some money now, that's in lieu. That'll save them $75,000 4 years from now. The company's MAR is 12% per year, and the inflation rate is estimated to be 3% per year. So we're given F equals 75,000. That's the number of then current dollars at time, what is it, time 4 years from now, I think. Spending 4 years from now. The MAR, the real MAR is 12%, but the inflation rate's 3%, and is 4 years, so we want to find P. And then solving equation 10.12, which was our essentially case 4. This is a case 4 problem. P is equal to F times 1 plus MAR sub F to the minus N. Okay, and MAR sub F, we basically use equation 10.6 to get that. We take MAR plus F plus the product, which gives us 15.36%. We plug that in, bring it back 4 years at that rate, and we get $42,349. That is essentially the present value of $75,000 4 years from now at the market MAR. That's what MAR sub F is. Got to learn a lot of new terminology and keep it straight. You got real rate, market rate. Remember, the market rate includes inflation. The real rate does not. Okay, it excludes inflation. Okay, we're going to work another problem. Example 2. An engineer deposits $10,000 into an account when the market rate is 10% per year and the inflation rate is 5% per year. Okay. Remember, the market rate includes inflation, so that 5% is already embedded in that 10%. The account is left undisturbed. In other words, no deposits, no withdrawals for 5 years. How much money will be in the account? Well, it's earning a market rate of 10%, and that's including inflation. So we got P equals 1,000. The market rate includes inflation, is designated as I sub F, and that's at 10% per year. How much will be, how much is F at N equal 5? So equation 10.7, we have F equals P times 1 plus I sub F to the N power, 10,000 times 1.1 to the 5th power, $16,105. That's part A of the question. Part B says, what will be the purchasing power in terms of today's dollars? So we're looking for the constant value of these F dollars here. And we must remove the inflation of 5% per year from the F to get the purchasing power, or constant value dollars, or today's dollars we call them. Use equation 10.10 and solve for P. Equation 10.10 is, this is really the purchasing power of F, equals P times 1 plus F, and that should be to the minus N. Solving for P yields P equals I'm sorry, this is that equation is going in the opposite direction. That is a plus N. solve that equation for p, and you get f times 1 plus f to the minus n. And you then, that's f is 5%, and this is 5 years as well, n is 5. So you do that, and you get purchasing power of those, let's see, $16,105 have a purchasing power of $12,619 because inflation has eaten away at the purchasing power, okay? Part C, what is the real rate of return? Okay, the real rate. So then the author has to solve for I, okay? And remember, we're going to use equation 10.9 actually is where we do that solution. We start with equation 10.6. 10.6 was I sub f equals I plus f plus IF, I times f. This is equation 10.6. We're going to solve that equation for I. And we did that just a few minutes ago to get equation 10.9. Equation 10.9 says I equals I sub f minus f divided by 1 plus f. And so we have 10% minus 5% over 1.05, which is 1 plus f, okay? And, or 0.1 minus 0.05, that's 10%, 5%, and 1 plus 5%. And then we do that and we get 4.76%. So that is, quote, the real rate that you're earning above inflation. And that will conclude today's lecture. And thank you for paying attention. Bye.